Living nature, energetic, in continuous transformation, in never-ending succession of extraordinary phenomena. An active volcano, the geological element that surely more than any other demonstrates just how the planet, playing host to man, is overflowing with life, in constant and extraordinary evolution. This is Mount Etna. It is at the highest altitudes of the volcano that Etna shows its true nature. But the summit eruptive activity rarely causes significant anxiety for those living on the volcano slopes. It is primarily characterized by often highly spectacular explosions, as well as lava flows that extend for a few kilometers from the craters. This animated reconstruction shows the development of summit lava flows over the last 300 years. Instead, the eruptions that cleave the volcano flanks are potentially more dangerous. Deep fractures propagate in its sides, giving rise to eruptive vents at lower altitudes. With the decreasing height of the emission of lava, the probability that lava flows may reach and destroy urban areas increases. This animation shows a time sequence of the lateral eruptions taking place from 1595 to 2005. In 1928, the lava razed the town of Mascali to the ground. In more recent times, other lava effusions have advanced down to the low altitudes, damaging tourist infrastructure, covering cultivated areas and farm holdings, posing a serious threat to numerous inhabited areas. But not just lava. The earthquakes accompanying the opening of eruptive fractures have at times caused destructions and death. The last part of the 20th century was characterized by a period of intense eruptive activity that culminated with the eruption of 1991-1993. An event of complex dynamic activity, also remembered for the substantial development of lava tubes. An underground network of tunnels created by the physiological cooling of the more external parts of the lava itself. A thermo-isolating shell that protects the burning flow of the internal molten lava, allowing the lava to travel for long stretches and keep its high temperature and fluidity. And it is precisely this phenomenology that is the main reason enabling the lava field to reach the gates of Zaferana Etnea. Regardless of hostile morphologies, the lava mass overcame valleys, buried the fruit orchards, and destroyed a number of farmhouses until approaching and threatening the town. The population, extremely apprehensive, demanded the intervention of the government. The Department of Emergency Management, known as Civil Protection, stepped in together with the High-Risk Scientific Commission. A sophisticated and articulate intervention plan was devised to obstruct the advance of the lava fronts with earth banks. The idea was to interrupt the feeding near the effusive vents where the mass of lava flows was entrenched in a single conduit. The complicated intervention in the high Valle del Bove gives the expected result. The flow is diverted from its natural channel toward the direction of the artificial one. As a consequence, the halt of the more advanced fronts can be observed, and the entire eruptive picture returns to the initial phases. But from those days on, the eruption certainly does not have the same thrust. Zaferana Etnea ceases to live with the threat of destruction. While Etna is emitting an enormous quantity of magma, roughly 250 million cubic meters, the system of surface feeding empties out and the volcano contracts, as amongst other things is indicated by terrestrial and satellite geodetic measurements, an evident sign of strong diminution or of internal tensions of the edifice. An eruptive cycle is over and the volcano feels to need to take a break, to rest. But already from 1994 onward, there was the start of a gradual and marked recharging phase, which in successive years would accumulate in an exceptional swelling of the entire volcanic edifice. In 1995, the magma also re-emerged at the surface through increasingly intense strombolian activity that occurred from two of the four summit craters, the Bocca Nuova and the northeast crater. In November 1996, the southeast crater also reactivated, and in 1997 it was the turn of Voragine to show signs of renewed vitality. The seismicity of the 90s and seismic tomography depict the internal stress linked to earthquakes and clearly show the effects of the accumulation of new magma in a zone of intermediate storage. In response to the internal accumulation of stress, the edifice expands constantly on the surface, as the ground movements detected by geodetic satellite measurements demonstrate. And so we arrive at the end of the second millennium, marked by an incredible series of paroxysms. More than 120 lava fountains between 1995 and 2001, proof of Etna's extraordinary power and unequaled beauty. But something new, or rather ancient, hovers in the air. Disturbing clouds of ash, and with them hazard, damage, and frequent moments of emergency. In fact, the intense explosive activity causes the formation of ash columns and lapilli that rise up into the atmosphere to more than 10 kilometers high. When the thick suspension falls to the ground, it makes the air almost unbreathable, causes damage to crops, accumulates on the roads and roofs, blocks road traffic, and in some cases, paralyzes air traffic. Alternating with these paroxysmic phenomena, which luckily only last some tens of minutes, are regular lava effusions from the southeast crater and Bocca Nuova. But this kind of activity, rather than a calamity, instead becomes the real motivation to attract tourists. The ensemble of eruptive and deformation phenomena of these years, however, shows that the volcanic system is charged, ripe, ready to break forth in spectacular and dramatic eruptions that would occur in the immediate future. We are in April 2001. Intense seismic swarms shake the southwestern flank. This is the magma thrusting upward with tremendous determination as it tries to reach the topmost strata of the Earth's crust. To make its way up, it fractures the overlying rock, thereby generating continual earthquakes. The state of alarm grows. The researchers of the Catania department of the INGV, the National Institute of Geophysics and Volcanology, indicate the unequivocal evolution of the events to those in charge of civil protection. On 12 July, the volcano breaks the impasse and a frenetic, ceaseless seismic crisis begins. The attention rises to the highest level. In the following days, experts from INGV illustrate the nature of the events underway and the impending scenario envisaged to the prefect of Catania and to those responsible for civil protection, namely an eruption of the southern flank of the volcano. On the night of 16 July, a decisive flaring up of the seismic signal heralds the final uprising of the magmatic mass, and on the morning of 17 July, the highest segment of the fracture field at the base of southeast crater gives way to the uncontainable thrust of magma, breaks and gives rise to a new eruption on the southern flank of Etna. Between the 17th and 19th July, the fractures descend until a height of 2,100 meters and open up as many as 7 different eruptive vents. Successively, the propagation of the fracture stops, as proves equally clear from ground deformation measurements. In this animation, the simulation of the lava flows obtained with physical mathematical models is reproduced in blue, while in red one may see the real path taken by the lava in the following weeks. The simulations of the expansion of the lava field confirm a relatively calm picture. The lava does not have the capacity to advance, which might represent a serious threat to the more exposed inhabited centers, in particular Nicolosi, the nearest town to the active lava fronts. Furthermore, structural and volcanological observations highlight that we are facing an eruption characterized by two distinct feeding systems of magma, substantially independent of each other. The eruptive vents at the higher altitudes draw directly from the central conduit of the volcano. They emit lavas that are already degassed, accompanied therefore by modest explosive phases. The lower vents, instead, are fed by an eccentric conduit, namely independent of the central one. They erupt magma that during the uprising did not have the chance to gradually free its gaseous phases. Consequently, a different magma-richer in gas emerges from these vents and sets off high-energy explosions accompanied by the formation of tall ash columns. Unlike the explosive phenomenology that characterized the 2000 activity in an impulsive manner, now the duration of the lava fountains lasts longer. The emission of dense clouds of ash is prolonged for entire days, and it is thus the reason for much more serious interference with the main air routes, severely affecting the working of the nearby international airport of Catania. Also, the everyday life of the population is seriously affected by the copious ash fallout that covers everything and penetrates everywhere, an unexpected phenomenon, especially with such vast proportions. It causes huge damage and is the source of notable hazards, both physical and psychological. On 9 August, after 24 days of intense activity, the eruption ended, and with it, that sense of anxiety concerning the ash fallout that had pervaded all and everyone for weeks. But, rather more than an ending, for the experts, it had the air of a truce. For them, the picture just didn't add up. Indeed, the energy dissipated during the eruption appeared to be decisively meager. Estimates of upraise and accumulation of magma between 1994 and 2001 led to believe that the volcano still had much energy to release. Furthermore, no diminution of the volume of the edifice could be seen. The deformations did not deflate. Instead, they showed a further swelling, and a widespread seismicity affected the entire area. To further awaken suspicions is the modest emission of sulfur dioxide, with clearly anomalous values. It is as if the volcano were holding its breath. Suddenly, during the night of 26 October 2002, the magma breaks the roof of rocks above the most superficial storage zone. It penetrates the southern flank of the volcano with extreme violence and rapidly rises along the same path followed and weakened in the previous eruption of 2001. This time, the seismicity associated with the intrusion of the magma occurred only a few hours before the eruption onset. The rise of the magma is extremely rapid. The warning was exceptionally close to the alarm. The situation is faced by the staff of the INGV with determination and readiness, with well-tested, efficacious and functional procedures. From the very beginning, for volcanologists, the entire phenomena presents such scientific peculiarities that the event may be considered a perfect eruption. On the southern flank, the picture is little different from the 2001 edition. The area affected by fracturing phenomena is the same as the previous year. Right away, the eccentric source feeding the violent, explosive and effusive activity appears identical. As in the previous eruption, the intense paroxystic stage gives rise to high ash columns. But this time, the northern flank is also split. The fracture field propagates quickly in an area already struck by the volcano in many previous circumstances, the so-called north-east rift. In a few hours, tens of newly aligned eruptive vents are formed. On the morning of 27 October, the lava rapidly reaches and destroys the tourist station of Piano Provenzano. Instead, the state of ground deformation appears different. The values are more marked in the eastern sector with respect to those of 2001. Furthermore, violent and superficial seismic swarms shake the Ionian flank of Etna, fracture the terrain, cut roads and damage houses. The effects are the response to a complex process that involves feedback between eruption, flank movements and earthquakes. The force of the eruptive fracture rouses the eastern flank of the volcano, which moves towards the sea by tens of centimeters. Its motion changes the tectonic structures of this sector, which shift suddenly and generate earthquakes. The INGV is mobilized and enters into action with all its human and technological resources. A multidisciplinary approach then follows, involving geologists, volcanologists, geophysicists, engineers and technicians. Subdivided into different groups and coordinated in a team effort, all focused on understanding the phenomenon in progress and outlining possible scenarios. The initial results are immediately made available to the civil protection, which is activated with urgency. The department chief, together with the president of INGV, receives the overall picture of the ongoing phenomenon from the Catania section. The high-risk commission also takes part, and the first evaluations prove to be correct and fundamental from the outset to understand the phenomenon and plan appropriate actions. The dramatic nature of the event and its rapid evolution require lucidity and readiness, organization and efficiency. Different problems immediately emerge to be tackled together with rigorous scientific method. The four main problems are propagation of the fractures, earthquakes, lava flows and ash fallout. The first aspect of fundamental importance is represented by the extension of the fracture field. The more they propagate at lower heights, the greater probability that the eruptive vents come closer to inhabited areas, thus increasing the danger. Fast, determined and unstoppable, the fractures of the first stage of the eruption extend 4 kilometers. They tear through the terrain, advancing with incredible speed, even at 500 meters an hour. But already after the first day of activity, the analysis of the ground deformations, the halting of the tilt variations and the seismicity, which in the northeastern sector starts to show focal mechanisms in compression, indicate that the fracturing phenomenon has become stable. No fresh outbreak is expected in the near future. However, the exceptional deformations of the entire eastern flank of the volcano keep the alert high on eventual and greatly feared energy releases, namely earthquakes. A little later, the earth shakes. In the late morning of 29 October 2002, a succession of seismic events with peaks of magnitude 4.4 strike the eastern side of the volcano. Further strong events are to follow in the successive weeks. These are energy shocks that are way beyond the standard for Etna, with particularly shallow hypocenters. The areas affected by the earthquakes are thus limited, but the damage caused, luckily only to property, is notable and the inconvenience immense. The INGV researchers draw up maps of the damage, providing civil protection a way to identify the areas affected and prepare their interventions, including legislative measures, on behalf of the people affected. Another problem of the eruption underway is the pressing demand for precise indications on the probable extent of the lava field. Does the town of Lingua Glossa risk being reached by the lava flow? The effusion rate of the eruptive vents is quickly calculated, and the most probable paths of the lava flows are simulated. It is immediately clear that the town does not run any risk of lava invasion. The simulations correctly point out the flows with limited extent and distance. After the hostility of the initial hours, in the course of which the lava attacks and submerges the tourist center of Piano Provenzana, the flows are fed for only a few days, causing damage almost exclusively to woodlands. On the southern flank, the simulations highlight two main directions of propagation, towards the south and towards the southwest. In both cases, however, the lava flows reach a maximum length of 4 or 5 kilometers, and the projections clearly indicate that the towns below are not threatened with real danger. Exact evaluations are promptly confirmed, allowing to immediately define the problem, alleviate the tensions and best formulate the interventions of civil protection. A real example of just how much social value scientific research has in such situations. Once again, the Etna Sud, the tourist station, lies in the sites of the lava flows. Once more, the spotlight is on the eruptive theater of the southern flank of the volcano. In a climate of real concern, but also of considerable media pressure, the INGV researchers carry out daily inspections of the lava field to constantly monitor the changing situation. In addition, frequent flyovers survey the area with thermal measurements, which highlight the extent and dynamics of the lava flows. It is now 22 November 2002. The overflight using thermal video camera observes that a branch of lava is moving towards the departure station of the Etna cableway and onto the Sapienza mountain refuge. The rapid simulations of propagation of the flow indicate the hostile intentions and the most likely path. On the basis of documentation provided by INGV, the civil protection experts plan and devise an articulate system of earth banks to change the natural path of the flow. The intervention, the outcome of specific expertise, but also of indispensable synergy, is successful. The flow is diverted, and the two structures, the historic icons of the Etna South Tourist Center, are saved. The violent explosive phenomenon, which from the beginning has characterized the activity of the eruptive vents on the high southern flank, doesn't give any hint of conceding to mediation. From the very start, the INGV foresees that the phenomenon will last a long time. The ash plume, now that the process of convective rising is over, remains at the mercy of the winds and is driven even for hundreds of kilometers, at times reaching the North African coast and the Greek islands. The problems are serious, owing to the ash which falls heavily and unceasingly for 3 months over large areas of the Etna hinterland, causing severe blows to the economy of vast zones of eastern Sicily. The recurring consequences that the vigorous emission of ash has on the safety of flights and on the regular working operations of the Catania airport and even Reggio Calabria become really unbearable. There are interruptions and in some cases the total stoppage of air traffic. The heavy impact of the explosive and diffusive phenomena on the daily lives of the population urged the National Institute of Geophysics and Volcanology of Catania to a constant and rigorous monitoring of the eruption. In addition to the irreplaceable presence of researchers in the field, the study method also makes use of the surveillance of the eruptive theater by a circuit of fixed video cameras that send non-stop images to the operations room. The fluctuations in volcanic tremor, the remote sensing of sulfur dioxide emitted into the atmosphere, and the sampling of erupted products all provide the INGV experts a set of useful parameters to define the state of the explosive and diffusive activity. The data acquired are transmitted to the Department of Civil Protection and furthermore then uploaded onto the internet, a fundamental aspect for the transfer of accurate scientific news and to regulate the relationship with the media, an important link between the scientific world and the public. An attempt, among other things, to attenuate speculation and fruitless panic, which is always lurking in the wings on occasions of hazardous natural events like those in progress. After 3 months of violent eruptive and deformation phenomena, the eruption ends on 28 January 2003. Roughly 40 million cubic meters have been emitted, and at least as many in the form of ash and lapilli. The eruption is therefore one of the most explosive events of the last century. It causes destruction to urban areas and woodlands, and significant damage to the tourist and business activities. The earthquakes struck Etna's eastern slope heavily. At the same time, the eruption has once again provided additional and formidable input for researchers who have verified the capacity to correctly recognize and evaluate the variations in volcanoes' state of activity by calibrating ever more sophisticated and reliable monitoring systems. A precious opportunity to improve and consolidate that spirit of cooperation with the organizations whose duty is civil protection, cooperation that takes pride of place when the safety of the people is at stake. This is the real challenge for the future, to explore scientific knowledge in depth within an exceptional natural laboratory as is Etna. To provide precise elements for an exact evaluation of the force in scenarios. To give efficacious support for an intelligent planning of the territory, which is respectful of an environment that is just as extraordinary as it is potentially dangerous.